A rock is dropped from a height of 120 feet. Its position t seconds after it is dropped until it hits the ground is given by the function s of t equals negative 16t squared plus 120. The first question is, how long does it take for the rock to hit the ground? When the rock hits the ground, the height is 0, meaning the function value s of t equals 0, which indicates the answer to the question. We set s of t equal to 0 and solve for t, which gives us the equation 0 equals negative 16t squared plus 120. And now to solve for t, we will add 16t squared to both sides, which gives us 16t squared equals 120. Next, let's divide both sides by 16. Simplifying, we have t squared equals 120 sixteenths, simplifies to 15 halves. There are two algebraic solutions, a positive and negative solution, but because of the application, we know time must be positive, and therefore we take the principal square root of both sides, giving us t equals the square root of 15 halves, which to 3 decimal places is approximately 2.739 seconds. To answer the question, how long does it take for the rock to hit the ground? The answer is approximately 2.739 seconds. Number 2, we're asked to find the average velocity of the rock from when it is released, which means from time 0 until it hits the ground, which is the time 2.739 seconds. So the average velocity is equal to the change in the height divided by the change in the time, which in our case, the change in height is going to be the initial height of s of 0 minus the height after 2.739 seconds, which we know is 0, which will write as s of 2.739 divided by the change in time, which is 0 minus 2.739. Well, s of 0 is the initial height, which is 120 feet, the height when time is 0, minus s of 2.739 is approximately 0, because we know the rock hits the ground after 2.739 seconds, and the change of time is 0 minus 2.739, indicating the average velocity is equal to 120 divided by negative 2.739, which equals negative 43.824, indicating the average velocity from when the rock is released to when it hits the ground is approximately negative 43.824 feet per second. Let's pause here and look at this graphically. We have the graph of the position function s of t in blue. We first found when the rock hit the ground, which is the horizontal intercept, approximately 2.739, 0, and then the average velocity is the slope of the secant line passing through the point at time 0, which is 0, 120, and the point when the rock hits the ground, which is 2.739, 0. The slope of this black secant line is approximately negative 43.824, indicating an average velocity of negative 43.824 feet per second. And then for the third part, what time after the rock is thrown will its instantaneous velocity be equal to the average velocity? Remember that the instantaneous velocity is found by determining the derivative function s prime of t. S prime of t is equal to the derivative of negative 16t squared plus 120, which is negative 32t, which we set equal to the average velocity of negative 43.824, and then solve for t by dividing both sides by negative 32. Again, rounded to 3 decimal places, 1.370. To answer the question, what time after the rock is thrown will its instantaneous velocity be equal to its average velocity after 1.370 seconds? And again, let's go back and look at this graphically. We just found the value of t for this point here, which is the point of tangency to the function s of t, where the slope of the tangent line is equal to the slope of the secant line, meaning the instantaneous velocity at this time, where t is approximately 1.370 seconds, the instantaneous velocity, which is the slope of the tangent line, is equal to the average velocity over the time interval from t equals 0 to 2.739, which is also the slope of the secant line. I hope you found this helpful.